we can talk about systems, and I'll really take a moment just to talk about three kinds of systems, and we might consider four, but the simplest system, which would be considered a standalone simple solar system. Consider this a simple, like a RV ventilation system, where a solar panel is connected directly to a fan inside the cabin of the RV. It's elegant, it's simple, it is totally off-grid. There are no batteries. It's solar panel delivering electricity to the load. These are elegant, simple, and given the right application, absolutely the most cost-effective. Related to, let's say, ventilation type system, along these lines would be a water pumping system. You could have solar panels providing, depending on the type pump, either this strategic type inverter I mentioned earlier, supplying power directly to the pump. Again, the pump works when the sun shines, delivers water when the sun shines, and it's a very efficient system, and again, does what it's supposed to do most efficiently. Other systems, of course, if you need power, again, off-grid, these are typically off-grid systems I just mentioned because they're standalone. If you need power, though, during times when the sun doesn't shine, then we bring in the concept of a battery. So once we bring in the battery, we may also introduce some sort of power converter, like an inverter, to provide power when the sun doesn't shine. Typically an inverter produces power at 120 to 240 volts and can provide applications. Of course, this could be an off-grid home, cabin, or RV, but here you have an inverter, battery, in addition to the solar panels. Remember, the simplest solar system, just go back, how simple it is. Solar panel, that's it, because your load is not really part of the system. That's your load. So solar panel is it. Then talking about the grid-connected homes, they are also elegantly simple. Grid-connected simple, and partly because they're simple because of the extreme engineering and sophistication of the inverter. So we have a black box, let's call it the inverter box. Specifically, the grid-connected inverter is a very sophisticated machine. They're universally microprocessor controlled. You don't tweak them. There's no knobs to turn. They simply work if they like what they see, and they don't work if there's something wrong. And there's, as in the typical nature of a digital machine. What the box does, of course, so the layout for a grid-connected solar system is, again, solar panels feeding power. I might say the one distinction, keep in mind, on all current grid-connected solar systems, non-battery systems, I have to say, is the inverters the solar panels are connected in a high voltage arrangement. That's a lot of people miss that, but that makes these systems essentially equivalent to industrial power systems. I mean, you have some very high voltages on the roof and in the conduit. These are just things to keep in mind. These are safe, they're code approved, but they do certainly put them in a class that's different from, let's say, the concept of a low voltage safe solar system. These are sophisticated industrial systems. But the sophistication, other than hooking the solar panels or daisy chained, think of it in that terms, technically they're connected in series to obtain a suitable high voltage. The specifics of the high voltage are relevant to the inverter that you choose. Different inverters have different input requirements, and that has to be matched to the solar panel choice. But other than that, this is the designer's field or area that we work in. Inside the inverter is some, as I said, very sophisticated computer, and it essentially decides a number of things. It looks simultaneously at the solar power coming in, the voltage particularly, and it looks simultaneously at the quality of the utility power being presented. If it likes both of these conditions, it will then connect. And when it connects, it passes then high voltage power from the solar panels transforms it, think of it as a DC transformer, and transforms it downward to the lower 240 volts. We're talking residential systems here, so 240 is a number. Keep in mind that in this technology, the voltage, you could have a commercial system operating at a higher AC voltage. Keeping it simple, we're talking about standard 240 volt systems here. Nevertheless, the inverter's job is simply to regulate and produce and transform DC power to clean AC power. That fundamentally is, I think, the outline of the overall, the difference between the three type systems.